So last week we created a PWM generator circuit along with the MOSFET that drives a motor. So this week I'm attempting to create a cassette deck mechanism. What I want in that is something that's speed adjustable and easily reversible with a simple flip switch. This is the schematic of the PWM generator, consisting of an oscillator and a comparator with two buffers. The output of that goes to the gate of a MOSFET, and an H-bridge controls the motor. This is PWM circuit now controlling, with the H-bridge here, controlling a tape motor. If I want to change the direction, I just have to change this. So let's change it and go there. Now we're going the other way. I can make it faster. Fast, slow. Other direction. That's just with the mechanism control from underneath. Got a flywheel to a motor controlled by this H-bridge circuit and the PWM generator with this MOSFET. And I could adjust it so that it's on CV mode by pressing this in. So let's do that. It's just cycling with the CV frequency. Turn that off. Now we're back to the manual controls of the speed. Let me change the direction on the fly. Pretty good. So now for the H-bridge, instead of using this little double switch that I have to control the direction of the motor, I've created this, which is a little makeshift looking early prototype test of concept, but basically it's a rocking switch that changes the motor direction in one way or another. And so right now I have it hooked up to this old cassette mechanism. And so if I could change direction with this little rocker switch on the fly. And the speed could be adjusted with this PWM controller right here, so I can make it faster or slower. So I'm gonna make it a little slower now. Let's see. And that's it. So I'd say that works pretty well. Nice little addition to the final tape gizmo circuit. Let's test this thing out. So now the MOSFET is being powered by a 12 volt circuit. That's the MOSFET right there. It doesn't even get hot. And so this is a PWM generator set as a speed controller. And right now I just have it going in one direction. So now this is the speed for a potential tape mechanism, right? So I have that at a very low duty cycle. If I was going to pick a duty cycle on this, let's see, let's get rid of the frequency. Let's go to duty cycle. So it's about 11% duty cycle, 10%. And that gives you a VRMS of 2.7 volts, and you see how slowly that spins. So the controller for this PWM signal is here. So I just didn't. So let's go to 20%. It's about 20%, and that's how fast it goes there. That's pretty good. Let's see. Wow, 40%. Man, look at that. That's fast. Alright, so looks like I'm never gonna need to go this fast. Now, if I try to cycle it through the control voltage, which makes it do, I'm gonna turn the motors off for a second and uncouple them. So now let's just do this and go to the duty cycle. Let's go to the control voltage, which cycles between almost 100% and 0%. And let's turn on the motors now and see what they do. Now let's test out to see the difference the frequency makes. So these motors are just regular run-of-the-mill little DC motors, little tiny DC motors, and they're attached to a 3-to-1 gear ratio to give more torque and slow down the speed. And so you can see at 15% duty cycle and 750 hertz, it spins at this speed. So let's keep it at 15% duty cycle, and let's adjust the frequency. The frequency is coming from the oscillator. And so let's watch what happens as I decrease the frequency. So they spin faster, and now it's at 500 hertz, and it's definitely faster. You can hear the sound too. And if you decrease the frequency more, at like 400 hertz, it's even faster still. And this is still only at 15% duty cycle. So there's a component of frequency here that matters. And it's still really fast at 40%. But I feel like it's drawing a lot of power because the light on my power supply keeps going off when I go to a very low frequency. So I think we're messing with the amperage here. So let me see, as I go to a low frequency, the light goes off, but the light goes back on. So minimum frequency there should be 400, but it spins slower at a higher frequency. So let me take it back to 750-ish. It's a very fine-tuned knob here. Yeah, close enough. Yeah, there you go, 750. And you see the speed, and this is at 10% duty cycle. So now, let's pick up the PWM duty cycle, and let's make it 20. So at 20, it's fairly good. And it goes really fast after that. But probably don't want to go higher than this. So it looks like in the end, let me turn off the motors here. So in the end, what matters most is the VRMS value right there, because the frequency changes the VRMS as you decrease the frequency. Let's decrease the frequency and see what happens. It goes down a little bit, or it goes up a little bit as you decrease the frequency. So as I decrease the frequency more, it goes up more subtly. And if I take it down to a very low duty cycle, so this is at 300 hertz, the VRMS is 2.94 and 10% duty cycle. As I increase the frequency, let's see what that does. My theory is correct, because now as I go up to a high frequency, let's go to 1 kilohertz here. 1 kilohertz used to be 2.94, now it went down to 2.5. So basically there's an optimal frequency that I don't feel like doing graphs and data to figure out, but it does make a difference in terms of the average voltage that's delivered. So that's the VRMS is voltage root mean squared. And so the average voltage, the higher that is, the more power that goes, or the more, the faster the motors spin. So if that is the case, then we just need to find a nice balanced frequencies. 1 kilohertz is not bad. Let's see what this looks like at makes a little bit of an audible noise. So if I turn on the motors, they spin nice and slow. They're getting 3 volts here, a 13% duty cycle. And if I increase the duty cycle, you can hear them rev up. And that's fast. But not as fast as if you go at a lower frequency. So it looks like the magic number for a speed that I could use is about 13% duty cycle, 10 to 13%. So somewhere between 3 volts and 5 volts is the magic number. 5 volts may be a little too fast. That's for fast forwarding a tape really, really fast. I might break it. Perhaps 4 volts. So now, if I put a 4 volt control voltage signal, let me turn off the motor here. If I put a 4 volt control signal in here, it seems like that is going to be the magic number for controlling this in an automated fashion without constantly adjusting both the frequency and this. We could leave the frequency at like 1 kilohertz here, and duty cycle will change according to the control voltage. So somewhere with the VRMS of that's all the way to 0. So somewhere between 3 volts and 4 volts is the magic number in terms of where it should be. And so we're going to try 3.5. Let's see what, we're going to get this to 3.5-ish. That's about 15% duty cycle. Let me see, maybe a little more. Close enough. Let's see, 3.5-ish volts. 16% duty cycle, that'll do it. Let's see what the motors look like when I turn them on. That's a nice speed to move a tape. I think so. I think that should work. All right, that's gonna be our magic number. Let's do it. All right, 3.5 volts. So let's figure out how to make that happen, and we'll go from there. So now I changed things over back to using this switch instead of that switch. And now I put in this LM7805 5-volt power regulator. So, and different MOSFET is controlling it, and this is going with 5 volts instead of 12 volts. and the main PWM generator is still positive and negative 12 volts and ground. But now if you look at the same voltage setting, 3.5 volts with a frequency of 1 kilohertz and a duty cycle of 17%, if I press the button, you hear the noise, the 1 kilohertz frequency, but you don't see anything moving. The motor's basically stalled out. So you're gonna need to increase the duty cycle. So let's do that. Let's do it to 38%. Does that make the motors move? Still not, still stalled out. Let's try bigger. Now it's moving. But barely. And that's at 58% duty cycle. If I go even higher, let's go to 75%. Now we're cooking. Looks like 5 volts is not the way to go for that. Looks like 12 volts it is. We'll just put this switch, replace this switch with that switch at 12 volts, and that should do it. All right. Now I've put this switch onto 12 volts, and we're using this MOSFET now instead of the board, but it's basically the same circuit as the one on the board. And we're using this switch, and now I have it going to 12 volts instead of 5 volts, and so I have it set to this modest duty cycle here of 18%, which gives us a VRMS of 3.71. So let's see what that does with the motors when I press this switch. And that's pretty good at 18%, and it's a 1 kilohertz PWM signal. And it's just all done with this little rocker switch that I made. The details of the rocker switch, I have 2 contacts, and it's basically just the H-bridge switch. And I have 2 contacts on the opposite side too. And basically what these do is I have little screwdrivers connected to a positive and negative terminal, and then I have the other contact going through these blue and white cables, and they're all connected together, and they're going to either the left side or the right side of the motor. And it doesn't matter which side, because that changes directions based on which side goes to positive, which side goes to negative. So it starts with the positive voltage rail and then goes into the drain of the MOSFET, and then the source of the MOSFET is just connected to ground, and the gate is coming from the PWM signal generator. So I have the oscilloscope probe measuring the PWM generator signal. So, and if I increase the PWM duty cycle, let's make it 40%. When I press this switch, it should rotate faster. Much faster. And it gives us a VRMS of 5 point, which I think is too much. So I think we only need about 4 volts there. So let's see, 4 volts maximum. So let's get that down to a duty cycle that gives us 4 volts maximum. Let's try 3.8, 3.75. How about that? And that should give us a nice, easy, controllable speed. Maybe a little higher. Let's try 4 volts. 4.2. Let's see what that does. That's reasonable. Yeah, so maybe 4 volts it is. Alright, that should be my optimum level. I just gotta figure out a way of measuring this on the fly without, well, I guess I could just look at the speed, but measuring it on the fly is better with some sort of voltage indicator. I could do that with some comparators, make it like a VU meter circuit in there, so I don't have to have the oscilloscope attached to it at all times, but I think it's okay. But this rocker switches. Pretty good. All right, now time to hook up some tape to it and thread it through all these gears and see what we could do with that. Now I have this little switch mechanism and the PWM circuit and a 5-volt power supply going to this MOSFET, which is controlling this tape. And so I could spin it in either direction. So that's pretty good. And here's the gizmo. I'm going to leave you guys once again with the schematic of the PWM generator and the MOSFET and H-bridge control for motors. And all of this is on the road to making my own a DIY cassette mechanism. So more in the next video. Thank you for watching.